This is a run through of WJEC Mathematics Intermediate Tier November 2016 paper. Okay, question 1 is normally some generic number work. Looking at this, we've got 0.4 times 0.7. You may be able to do this mentally, however, if you can't, the strategy is to use your place value, your powers of 10 to make the numbers whole numbers. So we've got 4 times 7. Now 4 times 7 is 28. However, 28 isn't our answer here. We need to consider the fact that we've multiplied both numbers by 10. Therefore, we need to do 28 divided by 100. As in the original sum, we made it 100 times larger by multiplying by 10 and then by 10 again. We now divide by 100 as an inverse operation to ensure that we're not changing the value of the answer, which gives me 0.28. Nice thing to remember here is 0.4 is a number less than 1, and we are multiplying by 1. That's something less than 1. Therefore, we are expecting our value to get smaller. 0.4 times by something less than 1, I'm expecting an answer less than 0.4. 0.28 fits there. On to question B, 13.8 take away 7.45. Again, you may be able to do this mentally, however, our written method would look something like this. Now 0 take away 5 I can do, but it's going to leave me with a negative answer. We don't want a negative there, so we exchange 1/10 for 10 hundredths, and then do 10 take away 5 to give me 5. 7 tenths take away 4 tenths gives me 3. Now I've got 3 units, take away 7 units. I'm going to exchange 1/10 for 10 units, and do 13 units, take away 7 units to give me an answer of 6.35. Question C, I've got 3 cubed, take away 2 to the power of 4. So 3 cubed, remember, is 3 times 3 times 3, which gives me 27. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. Therefore, 3 cubed take away 2 to the power of 4 is equivalent to 27 take away 16, and therefore we have an answer of 9. And part D, we have 9/10 take away 3/5. Now the first thing we need to remember when we're adding or subtracting fractions is we need to ensure that the denominator is the same, that they are split up in the same way. To do this, we consider the lowest common multiple of 5 and 10. So what is the smallest number that appears in both my 5 and my 10 times table? The answer to that is 10. So we want two fractions now, which have a denominator of 10. We're happy with the first fraction, 9/10, take away. Now we've got to find an equivalent fraction of 3/5, which is now tenths. That is 6/10. 9/10 take away 6/10 gives me 3/10 as an answer. Okay, moving on to question 2. So the first thing we've got to look at is 20% of 70 is the same as 70% of 20. Now the biggest misconception, or the biggest thing I see people doing wrong in exams, is they don't actually use the space for working, which is available down here. So let's actually figure that out. So 20% of 70 is the same as 70% of 20. So if we've got 20% of 70, well, 10% of 70 is going to be 7, times that by 2 is going to be 14. Then we've got 70% of 20. So 10% of 20 is going to be 2. 2 times 7 is going to be 14. Therefore, we are now happy that 20% of 70 is the same as 70% of 20. So rather than just guessing, I've done a simple bit of maths to allow me to get that as true. Moving on to the second question, then half of 8 is the same as 1/8 of a half. Now, when we see of in this context, we can think of it as a multiplication sign. So if we go down and do some workings out now, then a half of 1/8 is the same as 1/8 of 1/2. 1/2 of 1/8. 1 times 1 is 1. 2 times 8 is 16. 1/8 of 1/2. 1/16. Therefore, we are happy Again, by doing a bit of maths, it takes a couple of seconds. This is true. Okay, a number is halved, the answer is halved, and then this answer is halved again. This gives the same answer as dividing the original number by 6. So if we are halving, so a good strategy for this question would be to pick a number that is even, but we also know that it is in the 6 times table, so it divides by 6, which will keep our calculations fairly simple. So I'm going to choose the number 60. 60 is an even number, it's also in the 6 times table. So if I half it, that gives me 30. If I half it again, that gives me 15. So 30 halved and halved again gives me 15. However, we need to find half it again, so that is 7.5. So 60 halved gives me 30, halves again gives me 15, halved again gives me 7.5. However, 60 divided by 6 gives me 10. So we can therefore say that this answer is false. Dividing a number by 15 is the same as first dividing by 10 and then dividing the answer by 5. Similar strategy to the last one, we're going to pick a number which can divide by 15 and divide by 10. So I'm going to start off with 150, seems to be a good one. Dividing a number by 15, so 150 divided by 15 gives me 10. And then dividing it by 10, so 150 divided by 10 gives me 15. And then I have to divide that answer by 5, so 15 divided by 5 gives me 3. So therefore, when we divide it by 15, it's 10, and when we divide it by 10 and then divide that answer by 5, we get the answer is 3. So we know that one is false. Multiplying a number by 2.5 is the same as first multiplying by 10 and then dividing the answer by 4. Okay, so multiplying by 2.5, I'm going to pick 100 to start off with. So I've got 100 times 2.5 gives me 250. I'm then going to do 100 times by 10 to give me 1,000. And then going to do 1,000 divided by 4. A quarter of 1,000 is 250. We therefore know that that last answer is true. You may have been able to work those out mentally, but as I said, a most common misconception I see in the exam is people not using this space of working and just trying to work it out mentally. Yes, it takes you a little bit longer, but I'm more than confident it will guarantee you the marks. Okay, question 3. Again, you may be able to work this out mentally. I'm going to use some algebra to help us out here. So a shop has 31 plant pots. Some are blue, some are yellow, and the rest are red. There are 5 more blue pots than yellow pots. There are 4 times as many blue pots as there are red pots. So let's start off with our red pots. So let's call the red pots N. There are 4 times as many blue pots as there are red pots. So therefore, for the blue pots, we can write this as 4 times as many for N. And there are 5 more blue pots than there are yellow pots. So the yellow pots is going to be my blue pots, 4N. There are 5 more blue, so that means I'm taking away 5 to get the same amount of yellow. Therefore, we know that these 3 added together gives me 31. So N plus 4N plus 4N minus 5 gives me 31. Collecting my like terms, N plus 4 lots of N plus 4 lots of N gives me 9N. Take away 5 is 31. I then solve this. So I add 5 to both sides to give me 9N is equal to 36. And then divide both sides by 9 to give me N being equal to 4. Thinking about our answers then, red was N, so we've got 4 red. Blue was 4 lots of N, so 4 times 4 is 16. And yellow was 4 lots of N, take away 5, so 16 take away 5 gives me 11. As a check, 16 plus 11 plus 4 gives me 31, so I'm happy with that. Question number 4. Write down the next two numbers in the following sequence. Again, a little bit of exam technique here for you is to identify the difference between the two numbers. So the difference between 33 and 26, I'm subtracting 7. The difference between 26 and 19, I am subtracting 7. The difference between 19 and 12, I am subtracting 7. Therefore, I know that I'm going to subtract 7 to give me 5 and subtract 7 to give me negative 2. On to 4 part B then. I'm just going to zoom in to help me explain here. Simplify the expression 10g, take away 5f, take away 3g plus 3f. So remember, we can only collect like terms. So we can only bring lots of g together, lots of f together, lots of x squared in a different question, wherever it might be. So I've got 10g, and then I'm going to take away another 3 lots of g. So 10 lots of something, take away 3 lots of something gives me 7 lots of something. And now I'm going to start off, I'm going to put a different symbol around this to help me make sure that I don't make any mistakes. So I've got negative 5f plus 3 lots of f. So negative 5 lots of something plus 3 lots of something leaves me with negative 2 lots of something. So the answer there, simplifying that expression, is 7g take away 2f. And part C, finally, use the formula 2t is equal to m plus 3k. And we want to find the value of k when t is equal to m 11 and m is equal to 4. First thing we're going to do here is substitute in what we know. So we know that t is equal to 11, and whenever we substitute we put in brackets. So 2 lots of 11 is equal to 4 plus 3. Okay? So I'm now at the point where I've got 22 is equal to 4 plus 3k. We're now at our level 1 equation, and we can solve this by going through our normal steps. So we're going to subtract 4 from both sides to leave me with 18 is equal to 3k. We're then going to divide both sides by 3 because we've got 3 lots of k. So in order to find one lot, we need to split it up into 3 equal groups. So 18 divided by 3 is equal to 6. So the value for k is 6. Okay, we want to question 5. So we've got 2 cards here, and a player chooses 1 red card and 1 green card. The player scores the sum of the 2 numbers. So the keyword in the question there is sum. Sum means addition, so we're going to add the 2 things together. So for the first mark we need to complete the table. So 1 plus 6 is 7, 1 plus 9 is 10. I'm just going to do this quickly. Okay, so we've done that. Part B then. A player wins a prize if the score is more than 9. Sophia plays the game once. What is the probability that she wins a prize? So again, more than 9. That means we don't want to include the number 9. More than. We don't want to include that number 9. So we go through and say that the number of scores above 9 is 1, 2, 3, 4, 5. So we have 5 opportunities where we can get a score greater than 9. However, this is not a probability. This is the most common mistake people make with this question, is put 5 down. A probability, remember, is the chance of getting something, and we can write that as a decimal, a fraction, or a percentage. So there are 5 possible winning scores out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 scores. So the probability of winning is there are 5 chances of winning out of a possible 12 possible chances. So therefore, the correct answer for part B is 5 12ths. 60 people play the game once. Approximately how many people would you expect to win the prize? Now, there are lots of ways you can answer this. I find the easiest way is to make some equivalent fractions. So we know that 5 out of 12 people would win. As an equivalent fraction, when we now have 60 people playing, so 5 out of 12 people would win, we want to find out how many people win out of 60. So 12 has been multiplied by 5 here. So to keep this equivalent, we do 5 times 5 to give me 25 people would win out of 60. However, we cannot leave this as an answer. We need to say 25 people. If we left it as 25 60th, we're saying 25 60th of a person would win. Okay, on to question number 6 now, and we've got our first OCW question. Now, the organisation for the communication of writing marks in maths does not mean leave a massive paragraph at the end of your answer. It means that you've got a systematic layout and that you are using the appropriate units at all points. That's the two things we're going to keep in mind. These area questions are quite common. The first thing I would do is annotate the diagrams with every bit of information they give you. So they tell us we've got a right angled triangle, BCD, is joined to a rectangle, ABDE as shown below. The area of the rectangle is 45 centimetres squared. So let's write 45 centimetres squared in there. Calculate the area of the right angled triangle. So the area of a right angled triangle we know is base times height divided by 2. So we need to find out the base and the height of the right angled triangle. If I mark that in red here. Very often with these questions we have to use parts of the shape they've given us in order to get to the values that we know. For example, we can find the value of the height of the triangle here by using the area of the rectangle that we've been given. So the area of a rectangle is base times height. We write that formula down and then we can put in exactly what we know. So we know that the area of the rectangle was 45 centimetres squared. That was given to us in the question. We know the base is 9, which is the length AB, times by a height. Therefore, 9 lots of my height gives me 45. So in order to find out what one lot is, I'm going to divide by 9. And therefore, I have my height being 5 centimetres. Notice how I've ensured that there are units on my answer. That is imperative to ensure I get the two organisation for communication and writing. So I can now put 5 centimetres on my diagram. And this is where now we can look at our diagram again and we compare opposite sides. The parallel sides here, so between 9 and 15. If this line, B to C, and I'll do this in yellow, so if this line was carried on here, it would be worth 6 centimetres. Because I've got the length E to C, which is 15, and if I extended A to B to make a rectangle, I would get 6 centimetres there. Therefore, this length must also be worth 6 centimetres. So the length D to C must also be worth 6 centimetres. So we can now say the area of the right angled triangle is going to be base times height divided by 2, the formula that we used earlier on. And I now know that the base is 6, the height is 5, I'm going to divide that by 2. So 6 times 5 is 30, 30 divided by 2 is 15, and we've been working in centimetres squared because it's an area. So you can see there I've got a clear layout of what's going on. I've got calculations that include units, and this will guarantee me my two organisation and communication in writing marks. I don't need to write a massive paragraph at the end as some of you have been doing. Okay, looking at some solving equations now. So we've got W divided by 5 is equal to 10. I'm more than happy for you to think about these mentally. What number divided by 5 gives me 10? Our answer would be 50. If we wanted to solve this with a little bit more of a written method, we can say that the inverse operation of dividing is multiplying. So we'd multiply both sides by 5 to give me W being equal to 50. And again, 42 divided by what number gives me 7? What number goes into 42 7 times? The answer is 6. This one's a little bit trickier to do with a written method, the first thing we'd have to do is multiply both sides by x to give me 42 is equal to 7x, and then we would divide both sides by 7 to give me 6 is equal to x, which we found out earlier on. The most common mistake people do here is they do 42 times 7. That is wrong, because we are dividing by x. If we had x divided by 42 gives me 7, this would then be the correct calculation. So just be careful when x is the denominator of the fraction, we do need to take that extra step in order to solve it. And we now have a part C where we have unknowns on both sides. Remember, we don't want to solve it in this format, we want to turn it into a level 1 equation first. So we identify either the smallest value or the most negative value of the unknown, which in this case is my 9y. So the first thing we're going to do is subtract 9 lots of y from both sides. 13 lots of y, take away 9 lots of y, leaves me with 4y. Take away 5, and then 9y, take away 9y, leaves me with nothing, so 0, so I'm left with my positive 27 here. This is now back to our level 1 equation, which we can solve using our inverse operations. So we're going to add 5 to both sides to give me 4y is equal to 32, and I'm then going to divide by 4 to give me y is equal to 8. Okay, question 8. Again, this is just trialing some numbers and seeing what happens. So, an even number plus an odd number. 2 plus 3 gives me 5. So the initial answer is odd. Let's just try that with two different numbers. 4 plus 5 gives me 9. My answer is odd again, so I'm happy that this answer is going to be odd here. An odd number plus an odd number. 5 plus 3 is 8. 11 plus 17 is 28. So again, even. An even number times an even number. Well, let's have a look. Try some numbers. 2 times 4 is 8. 6 times 8 is 48. So I'm happy there. The number is even also. An even number times by an odd number. 4 times by 3 is 12. 8 times by 5 is 40. So I'm happy that one is even as well. An odd number times an odd number. 5 times 3 is 15. 7 times 9 is 63. Both numbers are odd. Okay, on to question 9, which is an averages question, and this is how averages tend to be asked now. There's not a list of numbers and ask you to find the mean, median, the mode. We need to problem solve. However, we can be quite clever with what we're doing to ensure that we get at least one of the marks. So reading through, we know that they're between 1 and 9 inclusive. Inclusive means that I can have the numbers 1 and 9 in my set of 5 numbers. They have a median value of 6, so the middle value's got to be 6. Now, a little bit of exam technique is to write the values below until you're very happy, you're certain with what you want, then put it in the box. So we know we've got a median value of 6. Actually, I can put that one straight in. The median value is going to be 6, so it has to be the middle value. They have a range of 7, so the biggest take away the smallest must be 7, or the difference between the smallest number and the biggest number must be 7, and their mean is 5. Now, this last part is the key to unpicking this question. Their mean is 5. Now, to calculate the mean, you do the total of the pieces of data divided by the number of pieces of data. And we need to find this total in order to help us get these questions. So, filling in what we know the mean is 5. We don't know what the total is, so I'm just going to call that T. And we know the number of pieces of data we have is 5 because they've asked us to identify 1, 2, 3, 4, 5 pieces of data. Now, solving this equation, what number divided by 5 gives me 5? We know that our numbers must add up to 25. So we're looking for 5 numbers, which when we add them up, they get to a value of 25. And they must have a range of 7. So let's start off then by putting the number 1 here. If 1 was my smallest number, and I had a range of 7, that must mean 8 must be my biggest value. At the moment, I've got 1 plus 6 plus 8. So 1 plus 6 plus 8 gives me 15 as a value so far. I need to get another 10, but I need to ensure that 6 is kept as a middle value. So number bonds to 10, I could put 2 and 8 in. Okay. Or I could put 7 and 3 in. So let's try that. 1, 3, 7. So 1 add 3 is 4, add 6 is 10, add 7 is 17, add 8 is 25. So these 5 numbers, 1, 3, 6, 7 and 8, fit all the conditions that we've got. They are between and including the numbers 1 and 9. They have a middle value of 6, they have a range of 7, and their mean is 5. 25 divided by 5 gives me 5. Now in the question it didn't say 5 different numbers, so you could have also wrote, as I mentioned, 1, 2, 6, 8 and 8 would have also been a viable solution here. Okay, question 10 part A. How many sides does this polygon have? We know it's got exterior angles of 45 degrees. So this is where we need to remember the formula that the number of sides in any regular polygon is 360 divided by the exterior angle. 360 divided by 45 is 8. So this polygon has 8 sides. Part B, a teacher will have to do with you in class because you need a compass and so on to do that. Moving on to question 11, we've got a little bit of substitution to do first. So 2 lots of, now we need to find the value when x is -1. This is where my tip to you about putting brackets in for substitution comes in handy. Take away 5 lots of -1, take away 1. Now, we need to follow BIDMAS here, so the first thing we do is -1 squared. This bit here, so -1 squared gives me 1. 2 lots of the number 1 gives me the number 2. Then again, following BIDMAS, I need to do 5 lots of -1. Well, 5 lots of -1 is -5. So at this point here, I'm going to be subtracting -5, take away 1. Now 2 take away -5. If I'm subtracting a negative number, that is equivalent to adding the positive value. So this is going to be the same as 2 add 5, which is 7, take away 1, which is 6. So -1 gives me 6. I do the same thing for the number 2 now. So 2 lots of 2 squared minus 5 lots of 2, take away 1. This is a little bit easier. 2 squared is 4. 2 times 4 is 8. Take away 5 lots of 2 is 10. Take away 1. So I've got 8 take away 10. That gives me -2. Take away another 1 gives me -3. Now we're going to plot these coordinate points onto our graph below. Now we know it's a quadratic graph, so we're looking for it to be either a U or an N shape, and we're looking for it to be fairly symmetrical. So I've zoomed in on the graph paper to help me plot the coordinates for you. So the first coordinate that we need to plot from our table is -2, 17. So x being -2, y being 17 is there. The next one is -1, 6, which is there. The next one is 0, -1. The next one is 1, -4. The next one is 2, -3. The next one is 3, 2, and 4, 11. Now, it's a quadratic graph, so we need to join these dots with a smooth freehand curve. Apologies for my not being the best using the software that I'm using. It's a little bit difficult to draw, but that is an idea of what your graph should look like. It is a U shape. It is fairly symmetrical, and I have joined the dots together freehand. Those are the key points in order to answer this question. Okay, for 12 part C, I've populated the answers. You need to draw y is equal to 5 on the graph paper, which is a horizontal line passing through the point of y is equal to 5. and then see the values of x where this intersected with the curve that we drew previously. Negative 0.9 and 3.4 are the ideal answers. However, the example will accept one either way of both those things. Part D then. Circle the equation below whose solutions are the values you have given in C. Now this seems quite complicated, it's quite wordy. However, we just need to think about what we've drawn. We've drawn the line y is equal to 5, and we've drawn y is equal to 2x squared minus 5x take away 1. So we've got two things where y are equivalent. The unknown y is equal to 5 and the unknown y is equal to 2 lots of x squared take away 5x take away 1. Therefore, we can say that 2 lots of x squared take away 5x take away 1 is equal to 5. Those are the solutions of x that we found in part C. However, in the question D, we notice that all of the equations are equal to 0. So to do that, we need to take away 5 from this side, which means we're going to subtract 5 from here. So 2 lots of x squared take away 5x, and then negative 1 take away another 5, it's negative 6, gives me 0. Do I have that as a solution? Yes. Okay, on to question 12. So a fair 6-sided dice and a fair coin are thrown together once. Circle the correct answer for each of the following statements. Now, this is a sample space question, and the most common thing people do here is don't actually work out what the sample space might be in terms of the number of possible outcomes. You may be able to do this in your head, however, it doesn't hurt to quickly draw a sample space. So we've got a coin. The two outcomes are head and tail, and we've got a die, a fair 6-sided die, where we have 6 possible outcomes. So we know that our outcomes are going to look like this: 1 head, 1 tail, 2 head, 2 tail, and so on, 6 head, 6 tail. Therefore, we are going to have 12 possible outcomes. For every one number on my dice, I could get a head or a tail. There are 12 possible outcomes in this experiment. Therefore, that answers part A. The probability of getting a 4 on the dice and a tail on the coin, well, I can only do that once if I get 4 tail. So that is once out of a possible 12 outcomes. The probability of getting a multiple of 3 on the dice and a head on the coin is what? So multiples of 3 are numbers which appear in the 3 times table, so 3, 6, 9 and so on. The only numbers which are relevant to us in this question are the numbers 3 and the number 6. And we want to get a head, so we can get a 3 in a head or a 6 in a head. So therefore that answer is 2 out of a possible 12. When I look though, that isn't in my list of answers. However, 1/6 is, because 2 out of 12 can be simplified down to 1 out of 6 by dividing each the numerator and the denominator by a factor of 2. Okay, 13 part A, make M the subject of the formula. Now when we're looking to make a value or an unknown the subject of the formula, we just need to keep in mind our solving equation skills. We are trying to solve this equation for M. So the first thing we are going to do is subtract 7 from both sides. Now writing this algebraically, I started off with an amount y. I've now taken away 7 from that, which leaves me with 6m. I've got 6 lots of m. I need to find one lot of m, so I'm going to divide it by 6. So I need to divide this by 6, which leaves me with y take away 7, all divided by 6 as my answer. Factorise 6x squared, take away 12x. So looking at our factorisation skills, then we're looking for common factors. So we've got 6x squared, take away 12x. So is there a common factor, a number that divides into both 6 and 12? The answer to that is yes, the answer is 6. And is there a factor of x in both? Is there an unknown x which goes into x squared and x? Yes, we have x there. Now we need to think, what do I need to multiply 6x by in order to get 6x squared? That answer is x. And what do I need to multiply 6x by in order to get negative 12x out? The answer is negative 2. Therefore, 6x squared factorised is 6x minus 2. Okay, question 14 part A. We've got 7.5 times 10 to the power of 6 divided by 5,000. Now what the example wants you to do here is put both numbers into standard form. So this is going to be 7.5 times 10 to the power of 6 divided by 5 times 10 to the power of 3. Now, when we do our division of standard form, we can split the fraction up. We can do 7.5 divided by 5, and we know we can do 10 to the power of 6 divided by 10 to the power of 3. Now we can work the second part out here. 10 to the power of 6 divided by 10 to the power of 3 using our rules of indices. We have the same base number, the number 10, and we are dividing. Therefore, we can subtract the powers. So this is going to be 10 to the power of 3. 6 take away 3 is 3. We've now got to do 7.5 divided by 5. There are lots of different ways you could attempt this question. I'm just going to move over. So you could, if I do it in blue pen, you could do it in a bus stop division and say 5 goes into 7 once, remainder 2, 5 goes into 25 5 times to leave me 1.5. Or you could say 75 divided by 5 is 15. However, I've made 7.5 10 times bigger to make it 75. So I'm going to divide this by 10, which gives me 1.5 as an answer. Either way, we get a value of 1.5 times 10 to the power of 3. In the exam, it is always worthwhile checking that our answer fits the rules of standard form. So does our number here lie between 1 and 9.9 recurring? Yes, it does. We're happy with that. And have we got 10 to the power of something here? Yes. So we're happy this number fits our rules of standard form. We can move on to the next question. 2.3 times 10 to the power of 3 plus 6.4 times 10 to the power of 4. There are two ways you can do this question, so I'm going to split my page in half and talk you through both of them. The first way to do it is to convert both numbers from standard form into ordinary form, do the addition, and then convert back. So 2.3 times 10 to the power of 3 is going to be 2,300. 6.4 times 10 to the power of 4 is going to be 64,000. And I then add these values together. So 0, 0, 3, 6, 6. And then converting this back into standard form, I get 6.63 times 10 to the power of 4. The second way, which can be a little bit trickier, is to convert both numbers to have the same power. Now, this means we'll have to break our rules of standard form. So I've got 2.3 times 10 to the power of 3, and I'm adding 6.4 times 10 to the power of 4. I'm going to convert this 10 to the power of 3 to 10 to the power of 4 by multiplying it by another 10. This means I have to divide this value by 10 in order to keep the value of my number the same, which leaves me with 0.23. I'm now going to add 6.4 times 10 to the power of 4. Now when I have the power of 10 the same, i.e. in this example they're both the power of 4, we can just add the two values together. So 0.23 plus 6.4 is 6.63 times 10 to the power of 4. Like I said, there are two ways of answering that question that I've outlined there. Whichever way you choose is completely up to you. Both will get you full marks in the exam. Okay, question 15. So we've got some information here about the square length being 2x plus 3y is 62, and x plus 2y for an octagon, each side of an octagon is equal to 72. Use an algebraic method. There's that key buzzword there. Use an algebraic method. That's what we're looking for. In our heads, we now need to be thinking simultaneous equations. So let's write down what we actually know at the minute. We know that a length of each square is 2x plus 3y. However, we've been told the perimeter of the square is 62, so we need to multiply this by 4 in order to give me the perimeter of the square. So 2x plus 3y all multiplied by 4 is going to give me 8 lots of x plus 12y, and we know that is equal to 62. Similarly, we know that x plus 2y is the length of one side of my octagon. Therefore, I need to multiply that by 8 to give me the perimeter, so that gives me 8x plus 16y. So I now know that 8x plus 16y is equal to 72. This gives me my two equations, which I can then work on my simultaneous equations for. Both of my x values are the same, the unknowns are the same, and they're both positive. Therefore, I'm going to subtract the equations. And I'm going to do equation number 2, subtract equation number 1. The reason why I'm doing that is I now do 16y take away 12y to leave me with positive 4y. If I did that the other way around, so 12y take away 16y, it would leave me with a negative answer, which I'm trying to avoid. 72 take away 62 leaves me with 10. I then divide by 4 both sides to leave me with y being equal to 2.5. Okay, so I've got one of the unknowns, y being equal to 2.5. I now need to find the value of x, so I can substitute that into anything that I like. I'm going to substitute it into equation number 2. So I'm going to sub y is equal to 2.5 into equation number 2. So I've got 8x plus 16 lots of 2.5 is equal to 72. So 2.5 lots of 16. Well, I've got 2 lots of 16 is 32. A half of it is 8. So 32 plus 8 is 40. So this leaves me with 8x plus 40 is equal to 72. I'm going to solve this up here now. So 8x plus 40 is equal to 72. I'm going to take away 40 from both sides to leave me with 8x is equal to 32. And I'm then going to divide by 8 to leave me with x being equal to 4. So I've got x being 4, y being 2.5. Okay, question 16. We've got a tree diagrams question with some information about Alwyn driving from Bangor to Cardiff. The probability to travel through Ryder is 0.7, and that's been populated for us. And they also tell us the probability that he travels through Ryder and stops for a break is 0.42. So let's write this onto our tree diagram. Again, a little bit of exam technique. The probability that he goes through Ryder and stops for a break is 0.42. So we've actually got 0.42 as the solution here. Now this word and, remember when it comes to probability, means multiply. So we've gone through Ryder and stopped for a break, which we don't know the value for, and that gives me 0.42. So we've now got to figure out the probability of stopping for a break. So we know 7 lots of 6 is 42, so therefore x must also be 0.6. Now, we can go through and complete the tree diagram. Completely here. Now that is for 4 marks. You get marks for finding out 0.6, but you also get marks for filling in the tree diagram properly. So for example, you've got 1 mark just for filling in this value of 0.3. Remember, each branch must start up to 1. So calculate the probability that Alwyn travels through Hereford but does not stop for a break. So we want Hereford, which is 0.3. But does not stop for a break, so times 0.4. 0.3 times 0.4 is 0.12. Okay, so question 17 is an inequalities question. So we need to be able to digest the information they've given us and be able to solve. So William has n marbles. Lois has 4 times as many marbles as William, but she's now lost 23 of them. Lois still has more, so that's a key bit. Lois still has more. Now, what lots of people do here is tend to just use trial and error to find n. However, the question clearly says write down an inequality in terms of n. and then use your inequality. So let's algebraically write down what they've all got. So William has got n marbles. Lois had 4 times as many, so that's 4n. However, she's now lost 23. So we've got 4n take away 23. So write down an inequality in terms of n to show the above information. So we know Lois has more. So we know 4n take away 23 must be more than n. That is the inequality here they're looking for. And now we solve this inequality to find the least number of marbles that William may have. So we solve this inequality like we would solve our equations. So the first thing we would do is subtract n from both sides. This leaves me with 3 lots of n. Take away 23 must be greater than 0. I'm then going to add 23 to both sides, which leaves me with 3 lots of n is greater than 23. And then I divide by 3. That leaves me with an answer as n must be greater than 23 divided by 3. Now we need to find the least number of marbles, so we're looking for a whole number. So our whole number n must be greater than 23 divided by 3. So if I do my 3 times tables, 7 times 3 gives me 21. 8 times 3 gives me 24. So 23 divided by 3 must mean that n has to be greater than 7 point something. So the next whole number greater than 7 point something must mean that n is equal to 8.